Venus, named after the Roman goddess of love, appears to observers after sunset as a dazzling diamond shimmering in the twilight. This planet possesses truly breathtaking beauty, but behind its radiant facade lies a genuine inferno. Venus is the second planet from the Sun, orbiting closer to it than Earth. It ranks as the third brightest celestial object in the sky, surpassed only by the Sun and the Moon. Its brilliance is so intense that people often mistake it for an airplane, and some even spread rumors of extraterrestrial origins, claiming it's a UFO. Like Mercury, Venus never strays far from the Sun in our sky, reaching a maximum angular distance of about 45 degrees. The best times to observe it are shortly after sunset or just before sunrise. Through a telescope, Venus reveals phases similar to those of the Moon and Mercury. When it's farthest from Earth in its orbit, we see its fully illuminated face, a full Venus. As it moves closer to Earth along its orbit, it appears larger in our sky, yet the illuminated portion shrinks from a full disk to a crescent. At its closest approach, about 45 million kilometers from Earth, Venus passes directly between us and the Sun. During this phase, it appears as a thin crescent, but its proximity makes it bright enough to be seen even through binoculars. Paradoxically, despite showing us only a sliver of its sunlit side, its apparent size makes it appear brighter than when it's fully illuminated, but much farther away. Venus's orbit around the Sun is tilted by more than 3 degrees relative to Earth's. Just as the Moon usually passes above or below the Sun from our perspective, Venus typically avoids crossing the Sun's disk, completing its orbit without alignment. But occasionally, due to a rare celestial alignment, Venus passes directly across the face of the Sun. This event is called a transit. Unlike a solar eclipse, where the Moon can completely obscure the Sun, Venus, being much farther away, covers only about 0.1% of the Sun's surface. During a transit, it appears as a small, dark circle, moving slowly across the solar disk. Centuries ago, transits of Venus held immense scientific value. Astronomers realized that by precisely timing the start and end of a transit from different locations on Earth and applying geometric calculations, they could determine the distance between Earth and Venus, and from that, calculate the scale of the entire solar system. This led to ambitious global expeditions to remote corners of the planet to observe these rare events. However, scientists soon discovered that Earth's atmosphere distorts Venus's silhouette, making it impossible to pinpoint the exact moments of contact with sufficient accuracy. It wasn't until the advent of radar and other modern techniques that precise planetary distances could be measured. Still, Venus transits remain a spectacular sight. They are exceedingly rare due to the unique orbital configuration of Earth and Venus. Transits occur in pairs separated by 8 years, followed by gaps of over a century. The most recent transits took place in 2004 and 2012. The next one won't occur until December 10, 2117. Venus is so bright that it can sometimes be seen in broad daylight. But why does it shine so brilliantly? Telescopic observations reveal a smooth, featureless white disk, completely shrouded in thick clouds that reflect nearly all incoming sunlight. This explains its luminosity. But where does such a dense cloud cover come from? The truth is, despite its celestial allure, Venus is a harsh and unforgiving world up close. In several ways, Venus is Earth's closest counterpart in the solar system. It's only slightly smaller, about 12,000 kilometers in diameter, 95% of Earth's width, and has 80% of Earth's mass. Yet if Venus is Earth's twin, it's a malevolent one. Orbiting about 110 million kilometers from the Sun, roughly 2/3 Earth's distance, it's natural to expect higher temperatures. But no one could have predicted surface temperatures soaring to 460 degrees Celsius, 860 degrees Fahrenheit, hot enough to melt lead. And that's not all. Venus's atmosphere is almost entirely carbon dioxide, with surface pressure 90 times greater than Earth's. To add to the discomfort, its clouds rain sulfuric acid, but the droplets evaporate long before reaching the ground. Yes, Venus is a true hellscape. Why is it so scorching? The culprit is a runaway greenhouse effect. Long ago, Venus may have been far milder, perhaps even hosting oceans of liquid water. But as the young sun gradually grew hotter over billions of years, it eventually heated Venus enough to evaporate those oceans. Water vapor, a potent greenhouse gas, accelerated the warming. The oceans boiled away, releasing vast amounts of carbon dioxide that had been dissolved in the water. This thickened the atmosphere and trapped even more heat. Temperatures rose so high that CO2 began outgassing directly from the dry surface, like pouring gasoline on a fire. The greenhouse effect spiraled completely out of control. Venus also lacks a global magnetic field, leaving it exposed to the solar wind. Over billions of years, this has stripped away lighter elements and much of its water, drastically altering its atmospheric chemistry. Today, sulfur dioxide dominates the upper atmosphere, and the clouds are composed of sulfuric acid droplets. These high-altitude clouds are brilliantly white and highly reflective, explaining Venus's dazzling appearance. This creates a striking paradox. Although Mercury is closer to the Sun, Venus is far hotter, precisely because of its extreme greenhouse effect. Given these conditions, the last thing one might expect on Venus is snow. Yet observations show bright reflective deposits on mountain peaks, phenomena scientists describe as snow. But it's not frozen water. Instead, minerals like bismuthinite and galena likely vaporize in the scorching lowlands, rise into the cooler upper atmosphere, and condense onto the colder mountain summits. If true, Venus experiences metallic snow, a testament to its alien nature. Other strange phenomena occur there too. Venus rotates extremely slowly. One Venusian day lasts 283 Earth days. At the equator, you could theoretically run faster than the planet spins. This sluggish rotation is likely why Venus lacks a magnetic field. Planetary magnetic fields, like Earth's, require rapid rotation to generate a dynamo effect in the core. Even more bizarrely, Venus rotates in the opposite direction, what astronomers call retrograde rotation. In a sense, this means its north and south poles are effectively swapped compared to most planets. The cause remains uncertain. Theories include a colossal, ancient impact that flipped its spin. But for now, Venus's backward rotation remains an unsolved mystery. If a human could somehow survive there, life would be surreal. The thick cloud cover diffuses sunlight so thoroughly that the surface is no brighter than an overcast Earth twilight, despite Venus's proximity to the Sun. The dense atmosphere also equalizes temperatures globally. The poles are just as hot as the equator. Because of its retrograde spin, the Sun rises in the west. And since a Venusian day is longer than its year, 225 Earth days, keeping a calendar would be chaotic, though probably the least of one's concerns. Venus has no moons. Its proximity to the Sun may have prevented moon formation, or any primordial satellites may have been stripped away by solar gravity long ago. Another curious fact: Venus is the most perfectly spherical planet in the solar system. Its slow rotation means it lacks the equatorial bulge caused by centrifugal force, so its polar and equatorial diameters are nearly identical. Scientists know little about Venus's interior, but given its similar size and composition to Earth, it likely has a core, mantle, and crust. Yet its surface is profoundly different. Unlike Earth, Venus shows no signs of active plate tectonics, possibly because water, which lubricates tectonic motion, vanished eons ago. Still, its surface appears surprisingly young. Around 1,000 impact craters have been found, evenly distributed and remarkably well preserved. Their uniform state of erosion suggests they all formed around the same time, roughly 500 million years ago. This points to a planetary-scale catastrophe, a global resurfacing event that erased all older terrain. The leading theory? Massive volcanic activity. Venus hosts 167 volcanoes over 100 kilometers wide, a staggering number. Over time, they may have erupted so much lava that it flooded the entire planet. Supporting this idea, the volcano Idun Mons shows anomalous heat signatures, hinting at active magma beneath its peak. Additionally, atmospheric sulfur dioxide levels dropped sharply in the 1980s, possibly the aftermath of a major eruption in the 1970s that first spiked, then depleted the gas. Some speculate Venus acts like a planetary pressure cooker. Every few million years, the entire surface erupts in a cataclysmic renewal. The thought is unsettling. Venusian volcanism also produces unique landforms. Without tectonic movement, lava oozes slowly and stays in place, forming vast, flat structures called pancake domes. Dozens of kilometers wide, but less than a kilometer high, these domes suggest extremely fluid lava, likely kept molten longer by Venus's scorching surface temperatures. One final note. By international agreement, all surface features on Venus, mountains, plains, and craters, are named after notable women or goddesses from world mythologies. This honors both the planet's namesake, the Roman goddess of love and beauty, and celebrates the achievements of women throughout history, a fitting tribute on this enigmatic world. In summary, Venus, though similar in size to Earth, boasts an extraordinarily dense atmosphere that drives the most extreme greenhouse effect in the solar system, making it the hottest planet. It rotates slower than any other planet and spins backward, a unique trait among major celestial bodies. Cataclysmic volcanic activity reshaped its surface 500 million years ago, and evidence suggests such geologic fury may still simmer beneath its clouds. Venus is not just a beautiful evening star. It's a world of extremes, mystery, and stark, metallic beauty.